moons properly. There was too much dust, too much light pollution. So we're going to a different location tomorrow.
Okay.
Problem with my place is I don't get too much time. There is a hill behind, and things go behind the hill. Okay, Pushkaraj is back.
Can you hear me now?
Better.
Okay, I connected from my phone now. So,
okay. Are you ready?
Yep. So I'll have to share my screen because I have a small presentation for you guys. So,
okay.
And I see the screen sharing is disabled.
Yeah. So our host will hand over control to you, Tarun, and then once you're done, you'll have to hand over control back to the name that you see, Tarun Bhagat.
Okay, perfect. Sounds good. Yeah.
No need actually, because if he's going to be sharing the presentation, then he can be the host.
And Tarun, have you turned on recording?
Yes.
Okay. So Pushkaraj, once we go live, I'll give a quick introduction and then hand over to you.
Sure. That sounds good. Yeah.
So Raghu, all over to you now.
Yeah, I'll just wait for it's 9:02. So let's wait for another 2-3 minutes. People are still coming in. I see right now 22. I'm looking for some familiar names. Let them all come in. Okay. Oh, we have somebody called Star Trekker. Okay. So Pushkaraj, how long will the presentation take? It's about 45 minutes.
Yeah, should be a bit more.
Okay. If it takes longer, we are okay. I mean, there have been times where sessions have gone till 2.5 hours. So it's up to you.
Okay, that's good. Yeah.
Some people may drop off towards the end, but most of them stay till the very end. Okay. So I'll begin. So welcome back, everyone, to the IITB Photography for Geeks and Newbies webinar. This is the 7th session. Last time we had Stephen take us through Lightroom, digital darkroom techniques. Today we have Pushkaraj Naringrekar. He will take us through equipment and techniques for astrophotography. Pushkaraj is actually a, how should I say, an astronomer, an astrophotographer, and he also likes to sing and plays guitar. And his daytime job is consulting for Citi. Pushkaraj was introduced to us by Jayesh Shah, one of our colleagues from Hostel Times. And over to you, Pushkaraj.
Hey, thanks, Raghu, for the introduction. So, good morning, everyone. Maybe good morning, good evening, good night. I am not sure if I'm very on what on which place of the earth you all have joined. So, my name is Pushkaraj, and I am currently located in Costa Rica. Well, just to correct, I am an amateur astronomer because that's the right term, for this field. I'm an amateur astrophotographer. So I've been doing this. I'm into this hobby for last more than 2 years now. So well, into astrophotography, I would say. Regarding astronomy, well, the stargazing had been my hobby since childhood. Like I used to look at the stars and all the time. So, and 2 years back, a friend of mine he added me into a Facebook group, and I was pretty impressed by the images that I saw on Facebook, like the nebula, the galaxies, and all that stuff. So I was pretty interested. So I thought, okay, why not, let's go a bit ahead and learn something about this astronomy because I already love watching at the stars. So let's find out what star I'm looking out. So that's how I entered this hobby, and then I started with pretty basic setup like just a plastic tripod, a DSLR. There was the Canon 300D, and the kit lenses. That's how I started. I had nothing because these hobbies were pretty expensive. So when I started, like I didn't want to invest much in this. So today I'm going to talk about the deep sky astrophotography with DSLRs. Because why? Because I use a DSLR. That's the only reason. So we're gonna talk about the DSLR astrophotography and especially the wide field stuff because I prefer a wide field, astrophotography because you capture like much details in that. You can go even more deeper, but I prefer to doing that because I love doing the deep sky, the wide field stuff. So I capture like more nebulosity, more nebulae, maybe some faint areas around the actual object which I want to target. So that's why I go for the deep sky astrophotography. So let's start with the presentation. Let me show you what the DSLR deep sky astrophotography is. So you must have seen such kind of images on the web, everywhere. So deep sky basically, so this is the prime nebula. It's called as the Lagoon Nebula, and you capture the area around it. So you capture the Milky Way dust. So this yellow thing you see on the right is the core of our Milky Way and some galactic dust there. And you have the Trifid Nebula here. So you capture much regions in one frame. So that's why I go for the wide field. Then this was the Milky Way I captured 2 years back, or probably 1 year back in 2019. Then this is called the Rho Ophiuchi complex. That's because this nebulosity is near a star called Rho Ophiuchus, and you have a blue horse head. It looks like a horse head if you invert it, and it's blue in color, so it's called blue horse head. The California Nebula. Well, this nebula got its name because it resembles the shape of the state of California in the United States. That's why it's called California Nebula. And all these things, I mean, this California Nebula, this is taken from pretty much light polluted area where I stay. It's like the bottle 6, so it's not pretty a dark sky. But yes, I'm gonna tell you how you can capture those from the light polluted areas too. Okay, so let's see how I did this and how you can achieve this. So first of all, what is astrophotography, and why should we do that, or why do we do that? Well, astrophotography is, as the name says, just photographing the astronomical objects. So it's a very easy terminology, and which any layman can understand. Most of the time, it is known as astro imaging. I call it astro imaging because I don't know. I like that term because it involves pretty much the post processing stuff and the stacking stuff. So it involves something other than just a normal shutter release. And why do I do that? Well, there are a couple of interesting reasons why do I do that and why should we do that. It's like, you come to know things that is going outside your planet. So when you wake up, what you see is just people all around and whatever your surrounding is. So, and with astrophotography, you will come to know like some things very interesting beyond our planet. So when you look at the stars, you're looking almost at the infinity. Well, not infinity, but almost at the infinity. So you come to know that there are pretty things outside our planet, and we are just a small dot in this universe. We are nothing in this universe. So if you go like a few million kilometers away from Earth, Earth will be like we see Jupiter from our planet. And then the second distinction is like you start exploring new places because see, for doing astrophotography, what you need is dark skies, probably a good landscape where you have a 360 degrees panoramic view so that nothing blocks your imaging session. So and normally we don't travel to such places, like for example, I discovered a place last month in Costa Rica. So that's basically kind of a meadow where all the cattle are there, like they're grazing on the grass and the stuff. So normally no one goes there, but I love that place because there are dark skies and it's an open space. So you start traveling more to get the dark skies away from the cities. Then the next important thing, what I feel about astrophotography is, it spreads awareness about astronomy because what happens, most I've seen like in at least in my case, I am kind of a guy like every time I go on a terrace on a balcony, I just look up in the sky. My neck is always up. So I have been facing these questions many times from my family, my friends, like what do you look up there? Is the same star, the same point of light that you see every day? There's nothing interesting. I mean, don't you get bored looking at the same star again? So that question is basically expected, because they lack awareness. They lack awareness about astronomy, what is happening outside our planet, what is happening in the space. So I believe like it can spread awareness about astronomy. For example, like I'm giving you a session now about astrophotography. So I'm telling you like when you see the images, you get interested. Oh wow, this is an nebula. It looks good. So that's something you can never see with your eyes. And then get interested in astronomy slowly, and then you start learning about the constellations, about the nebulae, the galaxies, and other celestial events. Then you come to know about there are meteor showers. I'm sure like 60% of the people in this world, they don't know like there's a meteor shower every month. Every month you see some meteors in the sky, but they are not aware of this. So with such sessions and with such with astrophotography, if they get to know about these meteor showers and the eclipses and the other events. And the other thing is like you come to know like how important dark skies are, because once you get into astrophotography, you start hating city pollution, because this hobby, trust me, is so addictive. Especially the deep sky is so addictive that at one point of time you'll start blaming the city pollution, that why am I staying here? That happens to me. I stay in a bottle class 6 sky, so that's kind of a semi-urban skies, but still I died to go into dark skies. So you become aware about the how painful the light pollution is. So that's those are the couple of reasons, interesting reasons why we should do astrophotography. Moving on to the next slides, I'm going to tell you like what are the main types. Well, these main types are not predefined or officially defined as such. These are the common types of astrophotography, I would say, like the planetary. I'm sure I've seen the images of some of you guys. Jay has shared me earlier, like some of you have captured Saturn, the rings that were beautiful. So that's basically comes from the planetary astrophotography. So then the second type is what I do is the deep sky astrophotography, where we capture the nebulae, the galaxies, at times comets, star clusters. Yeah, the star clusters are beautiful too, if you know where to look and how to capture them. Then is the nightscapes. Nightscapes is basically just the maybe a Milky Way or started with some foreground. So I call them nightscapes. Then comes solar, the lunar photography. Well, you may see that solar and lunar are also included under planetary astrophotography, but I just kept it separate because the sun and moon are not the planets. And these are the types which you normally see, but I divide this divide the astrophotography into two main parts. That is the track photography and the untracked one. So untracked is basically what you do always, like just a tripod and the camera. You don't track the stars. And the track photography is like when you actually use a star tracker or a mount like this here, and you actually start tracking the skies. And that's how you go to a longer exposures, and you get more details about the deep sky object. So I started with the untracked astrophotography, and then I moved to the tracked one. So I already told you what deep sky photography is. So it's just in photography to capture the deep sky objects. So I think I covered it while telling about the previous slides. So and this is a kind of a bit tricky, because what's important is focusing on the stars. So the guys who already have captured Saturn and the stuff, I'm sure they're already very good in focusing, because I've seen the image that was pretty sharp, so that's well focused. So, but yeah, the focusing on stars is very important, because most of the new guys who entered the astrophotography, from normal photography, they fail to achieve this thing, because achieving focus on star is kind of challenging for a beginner. So, because you cannot use a manual focus, the autofocus here. I mean, you can, but I won't recommend. It's like 1 in 100 you can get the focus exact. So we have to go for manual focus. So you have to practice manual focusing a lot, and you have to make sure the star is like, a pinpoint, sharp point of light, and not like a blur disk. Then the second important thing about deep sky is the polar alignment. So that has to be as accurate as you can, because the more accurate you do it, the more longer exposure you can take. Otherwise, you start getting star trails. So I'm going to tell you about how to do the polar alignment and the stuff in the in the coming slides. Next is the XA for the exposure, what you want to set. So that depends upon what kind of skies you are in. Like if you're in a city, then you cannot go for much longer exposures because the image will be basically washed out and be white. If you go into a dark skies, like there's no light pollution at all, then probably you can go for 5-6 minute exposure. I go for like 3 minutes. That's my sweet spot when I go to dark skies. But I even tried 5 minutes exposure. But uh, once I tried, I was not able to get the pinpoint stars with the 5 minute exposure. Maybe a bit of an incorrect polar alignment, but yeah, that was the only once I tried 5 minutes. And then the framing. The framing in deep sky is pretty challenging because most of the objects you see are not visible to your naked eyes. Most of the objects are the hydrogen alpha regions, so that your naked eye cannot see that. Even you cannot see them with telescopes very easily. So those can be seen only with the long exposure shots. So framing is pretty challenging in deep sky because you should know where your object is. You should know what are the areas you want to capture and how you want to capture. So that's why I think this photography is kind of tricky. It's not difficult. It's not so challenging, but it's tricky. Once you get used to these 4 items, these 4 points, you'll nail the astrophotography for sure. Next, we'll see what do we need for imaging the DSOs. DSOs is the deep sky objects, as I told. So those are the galaxies. Basically, everything beyond the solar system are the deep sky objects. So that can be galaxies, nebulae, clusters, maybe the comets, the stuff. Then what you need is basically a tracker. So tracker is just an equatorial mount. So if you see here, I have my mount here. So this is basically a tracker. So what you do is you just attach your camera here on this part. So it goes like this, and then it rotates, it goes like this, and then it tracks your sky. So that's basically a tracker. This is used to track your stars. I'm going to tell you how to use this tracker, how to align this tracker. I have a slide for that. So just to give a short introduction, this is what a tracker is. It's just an equatorial mount, which is motorized, and it counters the Earth's rotation to track the sky. Then you need a study tripod. Well, this thing is very important when it comes to photography, especially the astrophotography, because I started this hobby with a plastic tripod, and trust me, it was a disaster most of the times. Like especially when I came to Costa Rica, and I came here in August in 2018. So and in December, January here are like crazy. It's crazy windy. So it was a plastic tripod. I was on top of the mountain, and of course, I did not have my tracker at that time, so it was just untracked photography. So I set up my camera there. I was taking some exposures, and what happened? There was a sudden gust of wind, and it literally pushed my camera off the cliff. Lucky my lens was broken. I mean, luckily the optics were not harmed. Just the plastic thing, the body of the lens was broken, and so that's how it is. So you need a robust tripod because a slight vibration, a slight wind, can cause your star to trail. I have wasted like hours of data due to wind here. So for that, you need a very sturdy and robust tripod that can sustain the vibrations, the wind, and also the weight of your equipment. That's the other important thing. Then what you need is an intervalometer. So intervalometer is just a remote trigger, a remote shutter. So I have an intervalometer here. It's just you have to attach it to your camera and plan your shots, like how long the exposure is gonna be, what should be the interval between 2 frames, how many exposures you want. So you can plan using that. Nowadays cameras do have the inbuilt intervalometer, so you don't have to get this device. Or there are many applications or softwares too where you can control your camera exposures. So you have those options. So that's basically you need an intervalometer, because if you don't have this, trust me, you have to keep clicking the shots, staying awake and sitting near your tripod or camera all the time. I have done that when in the beginning I didn't have the intervalometer. I used to connect my camera using the Canon app, and I used to sit near my tripod the whole night, like clicking the button. So that's like a big pain. So these things makes the life simple. And next optional thing is like a dew heater. Well, if you are in like cities like Mumbai or some, you definitely don't need this because the temperature there is not that low. But the place where it's cold, where it snows, like temperature is like less than 5 degrees or maybe 10 degrees too, you face a problem of lens fogging a lot. So I would recommend using a dew heater. I have it for my setup, so I use it. So and it helps a lot. So it avoids lens fogging because even the lens condensation, yeah, man, that's a headache. I have wasted hours of data because of that. So these are the basic things what you need, for you doing a wide field deep sky. Well, if you want to go more deeper on the object, like only the specific part of the sky and not the wide field, you can replace the camera with the lens with the telescope. So you can do that. Next is, I'll tell you how can you do a basic astrophotography with just a tripod camera and lens. I mean, that's how I started. So first of all, it's easy and cheap because you don't need much gear. The camera and lens, which you already have it, a tripod, which you already have it. Because since you're photographers, these are the basic things that you will always have and always carry with you. Then the only drawback of this is like you cannot go for longer exposures. Why? I would tell you. So what happens is this, you have to follow this 500 rule. I am sure you must have heard 500 rule, like, to get the pinpoint stars. So that's basically just whatever focal length you are shooting with, just divide 500 by that number. So whatever number you will go, that's the maximum, amount of exposure you can go on a star. So for example, if I'm using a 10 mm lens, maybe, then just 500 divided by 10, that's 50 seconds. 50 seconds is the maximum you can go in one single exposure. And this rule is for full frame sensors. It doesn't work with the crop sensors. So with the APS-C sensors and all, this rule will not work. And like for example, if you're using a 250 mm lens and a full frame sensor, the 1 second is the max what you can go to get the pinpoint stars. And for APS-C sensors, I mean, I came across certain rules on the internet, but they didn't seem to work for me. So I found out, like, my own calculation. What I found out is like, a 250 rule for my cameras. So I saw, like, if I divide 250 with my focal length on my crop sensor, on my Canon APS-C sensors, I do get pinpoint stars. So I tried with my kit lens on 18 mm and I divided like 250 by 18, so that came somewhere around 13 seconds. So 13 seconds is the max I go for, with my 18 mm lens. So I get pinpoint stars. If I go like a bit higher, 15, I start getting, minute trails. So if you're okay with the trails, like, on looking at the phone screen, that doesn't matter. It won't be that prominent. But if you're looking at a big screen, then the trails are pretty prominent in 15 seconds too. So if you're using an APS-C sensor, try using a 250 rule. I would say that works perfectly fine. And you get a pinpoint stars with that. So I hope you understand this. You understood this rule. Do you have any questions on this? You can ask, or I'll move with the next slide.
You can move.
Pushkaraj.
Okay. Yep.
Could you please go over that again? If I have a, say, 200 millimeter length lens, 500 divided by 200 would be 2.5.
Yes.
So is that 2.5
for a full frame sensor? 2.5 seconds. Yeah, 2.5 seconds.
Okay, seconds. Okay, yeah. That's what I wanted to know.
Yes, one more recommendation. That 2.5 will be the maximum you can go. So if you are able to get some stars, a bit less than 2.5, that would be perfect. But if you still want to go, I mean, as long as you can, then that's the maximum, value, maximum number.
Okay, and I'm sorry, I may have missed.
No, that's okay. Actually, only... I realize I missed that. I did not say the seconds. So 2.5 seconds is the max you can go. For me, like for 18 mm crop sensor, it comes to 13.88 or something. So that's basically almost equal to 14 seconds. But I still stay on 13 seconds.
Right. Okay, but that's the exposure shutter speed. But how about the other EXIF, ISO, and is that something that you will cover later, or?
Yeah, I'll cover later, but let me tell you again. So all this configurations, it depends upon the what kind of skies you are in. Like if you're in a deep sky, you can go for maybe ISO 1600. So ISO 3200 and more is not recommended for deep sky because it will create much noisy images. So I found that like at 1600 ISO, the images are perfect. The noise is pretty much controllable when you do the post processing. So if you're in a dark skies, like bottle 3 or less, I'll explain the bottle scale. I was slide for that. So if you're in a bottle 3 or less, you can boost your ISO to 1600 and go with the 500 rule. And since you are untracked, you're not using a tracker, so I would just open your aperture as much as you can. So use the lowest f-stop what you have.
Okay. Thank you.
Yeah, you're welcome. So moving on next slides, I'll come to the mounts. So what kind of mounts do we have in astronomy? So one is the alt azimuth mounts. So alt azimuth mounts is simply, it's just like your tripod, nothing else. So it just moves around your X and Y. It's simple. And what this is best for the observation. I won't recommend this for photography, but yeah, since you are using an untracked exposures, you have no choice. So you have to use it for your photography too. So that's just basically just your tripod. And then with this, the 500 rule comes into picture because you have limitations, and this is useful only if you're shooting at a wider focal length. For example, if you're shooting at 250 mm on a crop sensor, so just an example, so 1 second is what you can go for with this mount. So in 1 second, you basically capture nothing, just a few point of lights in the sky. Except if you're shooting the Orion Nebula or maybe the Andromeda Galaxy, which are pretty bright. So I have captured Orion Nebula at 1 second exposures too. I would show you that picture at the end of this session. I have not added that in the slide, but maybe I can share with you later about this presentation or something. So I have captured that with 1 second exposures and around, I guess, 778 frames. The next important mount in the Astro is the equatorial mount. So this kind of mount is what you need for the long exposure photographies in Astro. So this mount basically moves across the right ascension and declination. So these are the coordinate system in astronomy. I have a slide for that too. I'll explain that too, how it works and how you can spot your objects with the array and deck. And these mounts are very necessary for tracked astrophotography because this is how you're going to track your stars, and you can go for longer exposures. I've seen people going for like 30 minutes exposure with it's crazy. Of course, they use the narrowband filters too, but yeah, so you can go for as long as you can with the equatorial mounts. And this I won't recommend for observational astronomy because using this mount is kind of hectic because at times your telescope turns in such a way that your eyepiece is like under the telescope and you have to go below the telescope and like look up. So that's gonna hurt your back or neck. So I won't recommend this mount for observation purpose. For observation purpose, alt azimuth mount are the best because it's easy to spot the object with those mounts. So these are the mounts. So basically a star tracker which I have, this is an equatorial mount. So this is the declination axis and this is the RA axis. So it basically moves like this around the array. So that's the equatorial mount. Then let's talk a few lines about, yeah. Yep.
I'm sorry, this is Mukul. Hey, on a couple of slides, you said this is this. Did you intend to show us something or that was just in response to the bullet? Like on the mount, you said this is. We are just looking at the slide, not at anything else, right?
Yeah, we are looking at a slide and
okay.
Are you not looking at my video because I'm showing the mount in my video?
No, we didn't. Even earlier, you said that once when you were going in depth about something, and you said this is
okay.
this.
Anyway,
this is what you do.
I'll come back to that. So when I come to the actual slide, I'll give you a reminder to look at the video. I'm going to show you some mounts.
So guys, you can pin Pushkaraj's video. That way, his video will stay always. Other people's noises will not interrupt his video.
Oh, I see. I was just looking at the slides. Thank you, Raghu.
Yeah.
Hey, Pushkaraj, one question. Those mounts,
Sure.
whether it's equatorial or the other one, do they fit on top
Mhm.
of standard photography tripods?
Yes, they do. They do. The alt-azimuth mount is just your normal tripod without a ball head.
Okay.
Okay, and
So if I
equatorial
remove the
mount,
ball head,
yes, if you remove
yeah,
the
go
ball
ahead.
head, you can use this. You have a wedge, which you get along with the equatorial mounts. I will try to remove this. So this is basically a wedge. So it fits on the normal tripod, and then you mount the like this.
Okay.
So it fits on any tripod. Only make sure you have a very robust tripod because this thing is heavy, and if it's not so sturdy tripod, then you may get experience some vibrations while tracking. I hope I made it clear.
Yeah, that is great. Thanks.
Okay, so let's move to the next slide. So let's talk a couple of lines about the DSLR and CCD cameras. Well, when it comes to deep sky, well, I was always prefer using a CCD camera, though they're expensive, and I don't have one yet. But you can, if you can, get the one. It's pretty much recommended because those cameras are more sensitive. I guess around 50% more sensitive to it, than the DSLR sensors. So you get more lights in shorter exposures. Then you have very little noise with those cameras. They give you very better dynamic range than DSLRs. But only thing, the sensors are a bit smaller, so you get a smaller FOV. But yes, if you're going for a very deeper on the DSOs, then I would recommend using these cameras. But DSLR are, they are not like on the lower end for sure, because I have done all my astrophotography with the DSLRs and I'm pretty happy with that. The only thing is, like, DSLR, you have to deal with some noise at higher ISOs. That's the thing, and you have to go for slightly longer exposures. But with DSLR, you can, the advantage is like the less cost, and you know it can be used for other types of photographies too. So you don't have to limit your camera for just Astro, except you are not modifying it, and you get a larger field of view with DSLRs. So with CCD, almost all the lenses fit with CCD, so you don't have to worry about that. You can use any lens, just use its mount for that particular CCD, and you can use that. So this is the only difference with the DSLR and CCD cameras. Well, there are cool CCDs too, where they have a cooling fan behind, so that way you can control the temperature of the camera, and you can simply avoid the noise in your images. So that's why CCDs are like more recommended for Astro. But yeah, let's talk about the DSLRs, because we are here to talk about the DSLR photography. I'm sure not everyone has a CCDs, except I guess someone has a ZW camera, right? ZW, someone who has taken the Saturn, I guess. So that's the one.
Yeah.
And
Hazifa
yeah,
has the person who's taken the Saturn. He has
yes.
a
So
ZU. Yeah, it's a
yeah,
CCD.
that's a pretty good camera. I know.
It's very good.
I have plans to go for these CCDs in future. I'm just, this hobby is like a never-ending expense. So I'm just, trying to save some money for that, and I have plans to go for those cameras and a better mount. Mount matters a lot in astrophotography, because larger the mount, larger the payload it will take, and you can get, better quality images. So mount matters a lot. So if this is I would say, the very beginners mount, the Star Adventurer, and there's one iExos mount. So these are very basic mounts for just a camera and DSLR and some small scopes. But if you're going for, like, maybe a 10-inch scope or 8-inch scope, then you'll need a bigger mount. So you have the Skywatcher AQ6R mounts and all. So I have plans to go for that in future. Let's see. But right now I'm gonna continue with the DSLR stuff. Then DSLR is normally a modded and unmodded. So modded is basically when you remove few of the filters from your sensor, and unmodded is basically the stock camera that you get in the box. So with stock cameras, the advantage is, like, you can use the camera in daytime too. But in case of modded DSLRs, they remove a couple of filters from your sensor. So we have different types of mods. I would say we have an enhanced mod, you have a clear glass mod, you have a IR UV cut mode, or you have a kind of a naked mode. So enhance mode is just when they remove the LP2 filter, and if you do that, you can still do a better astrophotography. You can capture the nebulosity pretty well, and you can even use that camera for daytime use with custom filters or maybe a custom white balance. Clear glass filter is just sometimes when you remove some filters from your sensor, you find challenges with focusing. So they just put a clear glass on your sensor, so that it helps you in the focusing. I have a camera which is the naked mode. So basically, I've removed all the sensors. I mean, all the filters on the sensor. So my sensor is directly open. So I capture like all the wavelengths, starting from ultraviolet to infrared. So it's up to you. If you want to modify your camera, you can do that. You can. Some cameras can be self-modded if you're pretty aware how camera stuff thing works. So you can do. There are YouTube tutorials how to remove a filter from your camera and modify it for photography, or you can get it done from some expert. So
once you
if
mod
you
your
want,
camera, can you use it for normal photography or only for astro?
well, if you use the enhanced mode, they just remove the LP2 filter. Then you can use it, but with the custom white balance, or maybe you have to use some filters. If it is a naked mode, if you remove like all the filters, then it's difficult. You can still use, but the images would be red because it will capture all the infrared wavelengths too. So all the image would be completely red. So I tried using custom white balance, but did not work quite good in the naked mode. So that's why I prefer you can buy a cheap used camera. That's what I did. I bought a used Canon T3. I got it for like some $140, so that was pretty cheap, and I just got it modified. So it is making a miracle. I mean, it works like a charm for me. All my images are with that image, and that camera I did not expect like that camera will perform so well.
Yeah, Pushkaraj, once
Yeah.
you have made a mod on your camera, right? So it cannot be used for normal photography, right?
No, I don't use it for normal now. I have my stock camera for normal.
And the picture is red. Can you process it in some kind of Lightroom or something like that?
I'm not sure how much can do that because the images are completely red. Maybe you can adjust some color balance and do, but that would be again hectic, a double, kind of a lot of efforts to put in. I'll have to try that because I never tried doing that because I have two cameras. But I believe like pretty quite. I mean, everything is possible in Lightroom and Photoshop. So probably you can still manage the colors and you can get the actual colors out. But then you should have a lot of patience and time for that.
And do you remove these filters yourself, or is there some service
No,
that does that?
I did it from a service guy here because I tried to open my stock camera once, but I was not able to open it. So and then I thought it's better not to mess with because I'll mess with the camera I have. So I got a new one in like $120 or $140, I guess, and then I just got it modified from a person here. Okay, so that was basically about the cameras, and now let's move on to the tracked astrophotography, which which is the main focus today. So the tracked astrophotography is, I already told you what it is. Like you track your skies with your equatorial mount with your trackers, and you need a steady tripod. So I would recommend at least an aluminum tripod for this. So that's pretty sturdy. I have a Manfrotto. I don't understand. I don't remember the model number, but I have a Manfrotto tripod that's pretty stable in winds too. Then the mount which I'm showing is the same mount I have. I think the image is a later version, so it has a Wi-Fi. My mount doesn't have a Wi-Fi, but it's the same mount basically. There's no other change, just the Wi-Fi feature is enabled in that. And what you need is an intervalometer, which I showed. That's a remote trigger. So these three things you need to have to start going to the track astrophotography.
Pushkaraj?
Yep.
Which is the make for your mount?
What? Sorry,
the make.
Get you.
Who is the manufacturer of your tracker?
It's the Star Adventure, the Skywatcher Star Adventurer. The Skywatcher is the manufacturer, Skywatcher USA. So
All right.
they have these mounts, yeah.
Got it.
And this is the Star Adventurer, yeah.
Okay, thanks.
Yeah. And intervalometer, you can pretty use anything. I have a Godox, I have a Chinese intervalometer too. So that's basically just to control space. Yeah.
The mount is Skywatcher. The tripod
Yes,
is Manfrotto, you said, right?
Manfrotto. The image is not of Manfrotto. I just got these
Yeah,
images
yeah.
from the internet.
But
Yeah,
you have
but
a
yeah,
Manfrotto tripod
I
and
have a
Skywatcher mount.
yes, correct, and the Canon T3 modified.
Okay.
So basically, this is my camera, and I use this Samyang 135. You can see in the video. So I use this Canon T3 modified and the Samyang 135 f2 lens.
And that foot on the lens mounts on top of this tracker?
Yes, so you have a declination bracket which fits. You see that green thing, so your camera fits on this like this.
Okay, okay.
Yes, and this thing goes on your mount, and that's it. And you need to have a counterweight because if you're using a heavy lens, yeah, so you need to have a counterweight. Otherwise, you will not be able to track it properly. Okay, so moving on to next, I'll tell you how can you capture those pictures. The way I have captured it. So pretty basic steps which you use for your regular photography to like plan your picture, set up your gear. The only few extra things which come under Astro is the polar align. That's the important thing. Third step, then you frame your target, like how you want to frame it, like where you want to keep the object in the center or on the corners, or maybe you want to capture like more nebulosity, so you have to frame your target. Then find the sweet spot of your exposure. So depending on how dark your skies are, you can find a sweet spot, like what works for you. Like normally I told you in dark skies ISO 1600 works perfectly, so you can go for that. And then you can uh, set your shutter speed, like how much exposure you want to go. Normally you put your camera on bulb mode because you're going to go for more than 1 minute. Like, so you put your camera on bulb mode and then you control your exposure with your intervalometer. So you have to find out whether 1 minute is enough, or you can go for 3 minutes, you can go for 5 minutes. Then take a test frame and just zoom in and just see if you're getting a pinpoint stars or if you have trails. If you have trails, then there might be three or four reasons. Like you may be out of your polar alignment, so you're not aligned properly, or maybe your gear is not balanced on the mount. So you have to balance your camera and the counterweight. So it should not lean on one side. It should move away freely. Like wherever you go, it should stop there and it should not come back. So that's the thing. Or the third thing can be, probably your everything is perfect, but your mount has some small errors, that's why it's not able to track for much longer exposures. So you have to reduce the exposure length then. But if you think everything is perfect, then the other couple of things can be the wind. Well, wind causes trails too. If you won't understand, like, we think that the wind it's just a breeze. It's not, it would matter a lot. But sometimes there's a sudden gust which moves your mount and you start getting trails in that particular image. Or at times, even when you walk near your mount, like last time when I went to image, I mounted my camera in a grassy field. So that was basically pretty soft. So even if a dog went running near it, I had trails. So those can be the reasons too. So well, those things you cannot control because wind and all these are not in our control. So but yes, so basically you have to look for these three things, like the polar alignment, the balancing, these two things, and if your mount is capable to handle such longer exposures. Then the next step is like take as many images as you can. Like more the images you capture, more the data you get, more you can removal of noise when you stack them. So I told, like, when I went for the untracked exposures, I took like more than 700 frames. So that's like 778 frames for the Orion Nebula. So, and when I go for track, last time I went for like a 4 hours of exposure. So those basically I had some 100 frames. 100 frames of each frame of like 2.5 minutes. So take as many images as you can, the more the better. Then take some calibration frames. So calibration frames are like, they are like darks, flats, bias frames. I'll talk to you. I'll explain this stuff. So darks, how you take the darks and flats. So, and there are some bias frames too. So darks is basically just to reduce your sense of noise. Flats is basically, it helps to deal with your sensor dust spots if you have in the image, or the vignetting that you get, on your lenses because of the lenses. So you can get rid of those using the flats. Then the next step is to stack your images. So I have a slide for stacking too, like what is stacking and where to do it. So you can stack your images, and then the last step is the post process. So with these steps, I'm sure you can get an amazing picture. Well, it needs practice, of course. I'm not saying that you will get this in the first attempt, because I remember my first attempt was horrible. I mean, if I look at them that now, I just feel like deleting it. But still, I've kept it like this as a memory. But yeah, as you move further, I mean, trust me, you're gonna get better with this, and these are the only steps you need for a DSO imaging. Then let's move on to plan your picture. Like, for the plan, you should know where an object is. Yeah.
One quick question. For the polar mount,
sure.
you are in the southern hemisphere. So what do you use the southern
Yes.
stars?
Well, no, Jay, I'm going to come to that. I have a slide for that too, for how to align with the hemisphere. Yeah. So I'm going to talk about the polar alignment specifically in north and south both, and also on the equator. I'll tell you how to do it. Yeah. So first thing is to spot your object. So spot your DSO. So there are a couple of things how you can plan your frame and spot like what you're imaging where and where your object is. One is the RA and declination. Okay. So RA and declination is the right ascension and declination. So I'll tell you what those are. I'm gonna keep switching between these two slides. So yeah. So well, on Earth, if you want to locate a point on Earth, we have the latitude and longitude, right? So it's the same thing we have for the celestial sphere too. So basically, RA is just a longitude which is on Earth, and the longitude on the celestial sphere is RA, and declination is just the latitude. So if you see, this is the Earth. So just imagine an imaginary sphere around the Earth. So like a bigger Earth which covers us. So our equator goes parallel to celestial equator. So half is celestial equator. So if you stand on the equator and look exactly towards zenith, like 90 degrees up in the sky, that's the celestial equator for you. Then this part, the horizontal lines, you say that on Earth, those are latitudes. On celestial sphere, those are the declination lines. And the vertical lines, if you go like this, so on Earth, those are the longitudes. On celestial port, those are the right ascension lines. So right ascension moves this way and declination moves this way, just as latitude. Like, for example, when you say you are like 10 degrees north of equator, so that's your latitude. So if this is your equator, you move like this, 10 degrees. Similarly, on declination, if someone says that it's 10 degrees from the 10 degrees declination, then from celestial equator is like 10 degrees. So that's how it is. And the main important thing is the right ascension is measured in hours, so hours, minutes, and seconds. And declination is measured in degrees, arc minutes, and arc seconds. So one degree is like 60 arc minutes, and 1 arc minute is like 60 arc seconds. So this point is called a vernal equinox. So that's basically a point where the celestial equator and the ecliptic meet. Wait, but what is ecliptic? Ecliptic is nothing but the path on which the sun travels. So for us, the sun travels like this. So the point where the sun meets the celestial equator is the vernal equinox. So that's gonna be your RA000, so 0 hours, 0 minutes, 0 seconds. So that's basically the point on March 21, where you have vernal equinox. So, well, this point is where, like, imagine you're standing on the Earth with the coordinates as everything as 0, like on the equator with longitudes 0, and you look at the zenith. So that's your vernal equinox. So if you know the RA and declination for any object, you can spot it. And yes, the best thing is this coordinates, I'm sorry, RA and dec for any particular objects remains the same throughout at any point of the year. Because the stars for us, they don't move. They're always there. if you see any time of the sky, I mean, any time of the year, the star will always follow the same path. So the array and deck for the objects, they don't change. Of course, they do, but it's take like around 26,000 years. So the next time this array and deck will be modified will be some 26,000 years later. So that's kind of a pretty long time. So you don't have to worry about that. So if you know the array deck, this is the best way to find your objects. The equatorial mounts which you get on the in the market, like the for the telescopes and the stuff, they do have the array and deck marking on it. They have the array dial and the declination dial. So you can simply put the array and declination on your mount, adjust it, and just put the scope. You will be pointing the object pinpoint. Oh yeah, of course the telescope has to be aligned, but yes, you can find it. So that's the easiest way. Only thing you should know the array deck of these objects. Then other thing, if you don't have the array deck dial on your mount, for example, this assay, the mount which I have, it doesn't have the array deck marking. So it's basically pretty difficult for me to calculate the array and the declination. So I use a star map. I use the application called Stellarium. So for Android, I use the Stellarium Plus. So it's basically shows which object is going to be at what point of the sky, at what angle, at what height, and how I have to frame it. So like for example, there are few objects are normally near certain stars. So I found that star, find a star in the application. I find a star in the sky. Then I can okay, this is the sky. So a bit left of that star is the object, so I have to frame that star in such a way. So you can use it to locate the object manually, like a star map. Stellarium you have Sky Safari, you can use those. But I prefer Stellarium because it's easy, it's accurate, and it has more objects. And it's it doesn't consume more space. Then you can use a technique called plate solving. But yeah, but for plate solving, you should have the your telescope and mount controlled by your applications, like there's an application called Astrophotography tool. It's a software where you can control your mounts, and you have to plate solve the image. So plate solve, basically you take one exposure and then the software compares that frame with its database and starts to it tries to match the star pattern, and then it tells you, okay, this is the pattern I matched, so these are the objects that are in your frame. So in that way you can use plate solving. Or you can use a go-to mount. So go-to mount is basically, it's an equatorial mount, but it has a remote control where you can put the object name. It is a computerized control mount, so you can program your remote and your scope earlier before setting up, and then you just put the coordinates, or you just put the name of the object in your remote, and the scope goes to that object automatically. Only thing that go-to mount has to be aligned to, so there's like you have to align to the polar alignment again. Yes, so you have to do that, and then you have to do a 3-star alignment for go-to mount, where you manually point to the 3 bright stars. Like for example, you point at a star called Sirius, and then you enter in your remote that okay, I have now pointed Sirius. Then you move your scope to a star called Aldebaran maybe, and then just tell your remote that I have now pointed Aldebaran. Just like do this for 3 stars. That's it, your scope is aligned. Now you can go to any object in the sky. Just put like M42, the Orion Nebula, and say go to, it will go to Orion Nebula. So you can spot your DSOs like that. Go-to mounts are basically, I've seen many people using go-to mounts for the planetary. So I hope, did you understand what array and declination is? Or do we have to repeat or tell anything? You have any queries on it?
No, well explained.
Okay, that's good. Thank you so much. Okay, now let's come to the first critical step, how to polar align. So what is a polar alignment? So if you see, your Earth moves from west to east, right? So we have an axis that goes to the North Pole and South Pole. Similarly, we have a celestial sphere where the stars move from east to west, and we have the North Celestial Pole and South Celestial Pole just parallel to our North and South poles. So when you track the sky, you have to track in such a way, that it actually moves exactly how the star moves in the sky. So for that, you have to align this mount. If you have to align this mount to the Polaris. So Polaris is basically a North Star. it's not exactly in the north. If you see, it's not exactly the north celestial pole. So north celestial pole is just a few degrees away from Polaris. So first you have to do is you have to find the Polaris. So you have to find this constellation called Ursa Major. In India, we call it Saptarshi. So it's a pretty big constellation. You can see in the north. So find this constellation. Just the two top stars, the Dubhe and the Merak. Just follow that line. You'll reach Polaris. That's one way to find Polaris. That's the only bright star in the way. If you go in a straight line, that's the only bright star in the way. So that's Polaris. Still, if you are not sure, what you can do is, just point your camera towards north. I mean, adjust your angle, adjust your the mount to, based on your latitude. So if you are like on 10 degrees north of equator, just align your mount to 10 degrees. So you on your mounts you have the markings here, 0 to 90. I'm not sure if you're able to see it. Let me see. Yeah. So you have the markings here for angle. So that's the latitude. So you have to set your mount based on the latitude. So once you do that, take like a few 1 minute of exposure in north. You will see all the stars have trails except one star in the center or wherever it is. So that will be a Polaris. Polaris doesn't show trails in 1 minute exposure. I have taken like 90 minutes of star trails. Polaris has shown a very, very, very slight movement. So that's another way to find Polaris. So whichever star which doesn't have trail on 1 minute exposure in north is the Polaris for sure. So you have to find a Polaris. Then once you set your mount, on that particular angle, the mount has an eyepiece backside. So this is a cap on it. So if you remove this black cap, you have this eyepiece. So you have to look through this eyepiece, and when you look through it, you see this dial, the clock dial, which you see on the right side. So you see the dial, and this mark is where you have to place the Polaris. So you have to rotate your clock dial in such a way that it comes in the clock position, like 0 up, 6 down, 3 to the right, and 9 to the left. And once you do that, you have to assign the Polaris on this particular line on the dial. Well, how would you find that? You have an application called SAM console, which shows at a particular time on your location where you should put the Polaris on. So you open this application, you go to polar clock utility, and then it will just make sure your GPS is enabled. Otherwise, you'll have to enter the coordinates manually. So just put the location on, and it will show that particular time the Polaris should be placed here. So now if it's seen the image, so on his local longitude, like 2 degrees 40 west, and around 5:36 p.m., the Polaris position is here. So when you look through this mount here, you place your Polaris on the dial on this particular spot. If you do that, that's it, done. You are polar aligned. Now you can go for longer exposures. I have seen many people doing a mistake that, like the last Saturday when I went to the astronomy session, like we had an event here for the Geminids meteor shower, and I went there. I saw many people had the same mount, and they were complaining that, how do you go for like 2.5 minute exposures? We can barely go over a minute. I can't even go more than. How do you go for like 3 minutes and 4 minutes exposure? Then I said, like, how are you aligning your mount? And then they said, like, they put the Polaris in the center. I said, no, that's not the way. Polaris is not your center. That's not your exact north. Polaris is a few degrees away from your north. So this center is the celestial pole, not celestial pole. But your Polaris is a bit away from that, and Polaris rotates like this around this north celestial pole. So I feel like you have to align the Polaris in this way. Use this application, and align the Polaris in that way, and then that way you can go for much longer exposures as you can. And few of the mounts, they had some errors, like if I was not able to set up the clock position properly, so the mounts are basically defective. So that's the other challenge you find when you buy your mount sometimes. So if you find a defective mount, just get it replaced immediately. So this is how you align in northern hemisphere. I mean, are we clear on that?
Yep.
Any queries? Yep. Okay. So this was in northern hemisphere, where you have the view of Polaris. What would you do if you're in a southern hemisphere? Well, because in south you don't see Polaris, right? You don't have Polaris in the southern hemisphere.
Pushkaraj, one question. Suppose you can't
Yeah,
see
sure.
you can't see Polaris. Is there any way we can do an alignment?
Yes, yes. So that's the third point. After I finish the southern hemisphere, I'll come to you. I mean, I'm going to talk about how do you do on the. I don't have a slide for that because it's difficult to show on a slide. But I'm going to talk about that. So how you align on an equator, because on equator you don't see Polaris, you don't see this. I mean the southern stars.
No,
So
my question is
can,
where I'm living, the Polaris is behind trees.
Yes, Jay. Yes, Jay. So that's basically the same scenario, just as equator where you don't see Polaris, even if you're on 25 degrees north, there are scenarios where Polaris is blocked by a building or maybe it's blocked by a tree. So I'll tell you that there's something called as drift alignment. I'm going to talk about that too. So coming to the next is a southern hemisphere alignment. So here, you don't have Polaris, but you do have a constellation called octans. So those octans is basically considered to be on the south celestial pole. Well, trust me, this is a very, very faint constellation. Like the stars are, I guess, in fourth magnitude. So, and your human eye has a limitation of 6 magnitude. Like a human eye can see a star till 6th magnitude only if the skies are very dark. So, and these stars which you want to align are in fourth magnitude. So those are pretty faint. So you really need to have very dark skies for that. Like if you're in a city, if you can spot the octans, that's well and good. I never tried that because I've never been to southern hemisphere. But then yeah, if you are to cities, I have seen with some people who are from Australia and New Zealand. So they say that it's pretty challenging to align in southern hemisphere, especially you're in the cities, because these octans are pretty faint. So the octans have these four of the stars which are in this pattern. So if you see through the sky watcher, like you see both this, like you have the one thing for Polaris like this, and if you click on the southern hemisphere here, you get this application and you have this pattern inside if you see through the scope of the mount. So you have to look for the star pattern and you have to align the stars in such a way, these four stars, that they coincide with the points in the mount. So that's how we do in southern hemisphere. So once you align this, you align for the south pole. But this is pretty challenging when it comes to light polluted areas, because I was just looking in the sky map. Like I had plans to go to Chile, and I was just wondering how I'm going to align there. So I was just going through few blogs, few YouTube tutorials, and the star maps, and I saw these stars are like in fourth magnitude, and I told my friend, like, how the hell are we going to align there? These stars are in fourth magnitude, so these are like pretty faint. Well, if you go to dark skies, that's not a challenge. But like if you're even if you are in like class 6 skies, +4 magnitude stars are very difficult to spot. But we don't have a choice. That's the only way in southern hemisphere. And now let's come to the point, like the question that Jay asked: how do we do it when we don't have Polaris in view, or how do we do it on the equator, or like a few degrees up from the equator, like 1 degree, 2 degrees, where the Polaris is very low? Well, we have something called as drift alignment. So drift alignment is kind of what trial and error method. So what you have to do is you have to set your mount to the latitude, as I told you. So for example, you are in like say 30 degrees north. So set your mount to 30 degrees. Use a compass and point towards north. Okay, and then you take one exposure. Let's say 1 minute exposure. You see the trails. You adjust your mount. Now that's completely a trial and error. If you see, like, after adjusting your mount, the trails are increasing, that means you went in the opposite direction. So you have to go back to the same direction again. So you have to adjust your mounts up, down, left, right, till you get pinpoint stars. I have tried this once last year. I had been to a place where there was no Polaris. I took like 2 hours to align this mount. But yes, I did manage, and I went for a 2-minute long exposure with the drift alignment. So, but yes, of course I utilized the half of my battery in that alignment, but it took like 2 hours for me to align the mount. So yes, it is challenging, but it needs practice. That was my first and the last time when I did the drift alignment. I never went back to that place again. I said, I'm not going to waste 2 hours every night, every time I go there. That's a pretty good place. That's a very good dark skies, but no Polaris. I said, no, 2 hours alignment is like wasting 2 hours of data, and 2 hours of data is like you get a very good image in 2 hours of data. So I never went back there and I never did the line. But yeah, that's the way just you can align, but it's a trial and error method. The only key points are like you have to align your mount to that particular latitude, and you have to use the compass to point to north, and then start adjusting your mount slowly.
Yep, thanks.
Yep. Then once you have your exposures, once you align, you start taking the exposures, you get the sweet spot for your image, you take like, let's say hundreds of images. So once you have your data with you, yeah, one more thing, always shoot your images in RAW. I mean, I'm sure you are photographers, you already do that, because I doubt there are hardly any photographers that shoot in JPEG. So always shoot in RAW. And once you have all the exposures, you start stacking them. So while stacking, you need like, 3 sets of images, I would say. So those are called the calibration frames. So they are like lights, darks, flats. There are 2 more, bias and I guess some bias flats, something like that. So, but I don't use this. So I use darks and flats basically. So flats, because sometimes I have dust on my sensor, so it can get rid of that. Or you are shooting wide, you may get the vignetting on your images, so you can get rid of those. So flats, and the darks where you deal with the noise, sensor noise. So what you can do is, while taking the dark frames, so dark frames is nothing but you take the similar exposure, just put your lens cap on. Don't move the focus, but just put the lens cap on and take exactly the similar exposure, the same exposure like that as you took your objects. Like for example, if you are going at ISO 1600, 2 minutes of exposure and say f4 maybe. So the dark should have the same exit. Like the dark should be of 2 minutes. It should be on ISO 1600. It should be on f4. Only thing, you'll have a lens cap on. So dark frames basically just has noise, no data. And the flat frames, what you can do is, flat frames is basically the focus is very important. You cannot move the focus for flat frames, because you point your camera lens to a very bright spot, like probably a blue sky which has nothing, just a plain sky. What I do is I use my laptop screen, I start like paint or word in it, and I use a white screen, I put my camera on that, and I take the flats. So to take flats, you have to put your camera on the AV mode, and then that's the exposure priority mode, the aperture priority mode, and then you put your camera on the AV mode and take like 20 frames. But the ISO still remains the same, the f-stop still remains the same. Focus should not be moved at all. You move the focus, you mess up the flats. You mess up the flats, it will mess up the entire image. So focus matters a lot. Temperature doesn't matter for flats. For darks, temperature matters. So you cannot take darks like, after coming inside your house after 1 hour. No, so darks has to be taken exactly where you take the images, because the temperature matters a lot for darks. And for bias, focus. So you can take bias after like 1 hour, maybe 2 days, but you don't change the focus. So if you have like a prime lens, I believe the focus is going to be more or less similar. So you can just take your master frames, you can just keep your sets ready. Like for example, take the flats on ISO 800, take it anytime and keep those frames set ready. So you can use those set anytime you want. So that's how you take flats. So while stacking, you have to import all these frames. Like lights are basically the data what you captured, the normal images that you capture. Those are called lights. So you import these these files in the stacking software as lights, darks, and flats, and then just stack them. So what stacking does is basically you're averaging the value of every pixel. So it helps in dealing with the noise very good, because I'm sure you must have some idea about stacking. So basically, when you take like 100 exposures, 100 frames, the data will be on the same pixel value. So it will be same, it will be fixed. The noise will be random. right? So noise won't be fixed, so noise will be random. So for that purpose, when you stack, it averages each and every pixel, each and every value, so that you go on averaging the noise, and the noise goes down, the signal comes up. So just boosting this SNR, signal to noise ratio, and that's the important step in stacking. Also, because you can go for 1 hour exposure too. If you have dark skies, if you set your ISO to low, you can go to 1 hour exposure. But if you go for 1 hour single exposure, you have more noise. So instead of that, just go to multiple exposures or shorter subs and then integrate them together. So basically, 2 minutes into 10 images. So that would be equal to a 20-minute single frame, just lesser noise and more signal to noise ratio. And then comes once you have the stack ready, then comes the final part, the post-processing. So you can use your favorite software to post-process. You can use Photoshop, you can use Lightroom, you can use PixInsight. I recommend PixInsight because that's the best. That's the best, trust me. It is paid, but it's worth. It's like 230 euros, I guess, but that's like one-time payment. But it's the best. You cannot compare an image processing in Photoshop to one in PixInsight. So that's how once you post-process the image, once you export, you have your image ready. So do we have anything else? Any questions?
Pushkaraj, what software do you use for stacking?
I use Deep Sky Stacker, so I'm going to show you. So these are the softwares which you use for stacking.
Okay,
so
that's
for
fine.
planets, yeah, lunar and solar photography, you can use a PIPP. So PIPP is basically a software. It's not a stacking software, but it helps you, to crop your images and to get your object in the center. So for example, if you're shooting a moon, and if you're shooting a video of it and then you extract the frames, it's gonna be in a different position, right? So with PIPP, you can crop your objects in such a way that you get all the frames with an object in the center of your frame, and then you take those images to auto stack it. So this is the stacking software for planetary images. So you can, guys, give me just 1 minute. My phone battery is like 5%. I'll be back in a minute. Okay. So yeah, you have this software called Auto Stacker. This is the best I found when it comes to planetary stacking. So when you export, once you export these objects from PIPP, the image from PIPP, you input that frames to Auto Stacker, and then just stack it. The tutorials are available on the YouTube. It's a very easy software to use. It just stacks in like 10 minutes, to be honest. And then what I do is when you export the stack, I open the stack in the tool called Registax. So Registax can also be used for stacking. It's a stacking tool too, but I like the stack of Auto Stack it more because it stacks more accurate. Registax, I have had few issues with stacking last time. It did not stack properly, but the Registax have an algorithm called wavelet processing. It is an amazing algorithm to adjust the sharpness of your object. So what I do is I open the stack in Registax and I just do wavelet processing there, and it gives a pretty sharp object. Like especially the moon craters, it gives very good details when you addition Registax. And once you export from Registax, you can, if you want to process more, you can take it to Lightroom or Photoshop and maybe some noise removal stuff. If you want to adjust some hue saturation, you can go there. And for Deep Sky, I recommend using Deep Sky Stacker because everyone uses that and it's the best stacking tool. So Deep Sky Stacker is what I use to stack the images. You have a sequator. If you are a very beginner and if you want to learn stacking, like how it works, then I recommend using a sequator. But because sequator has certain, the few of post processing tool, like it adjusts the light pollution thing and the stuff. But the stacks are not that good. As you move further, you will understand the stacks are not that good as sequator. But to learn how stacking works, you can use sequator. Then you have one called serial, and you can even stack in PixInsight. If you have a system with a good capacity, with good resources, you can use PixInsight. But it takes a lot of time sometimes because I tried in PixInsight. My laptop is like from 1980s, I guess. So I tried PixInsight to stack once. It took like 8 hours for me, which Deep Sky Stacker does in 20 minutes. So I use Deep Sky Stacker to stack.
Is that the only difference? Deep Sky Stacker and PixInsight, the time taken? But the quality, can you comment on the quality?
Quality, I would say PixInsight is the best.
It's
of
really
popular
very good,
processor.
right? It's really very
Yes,
good.
no doubt. That 230 euros that you will pay, you will not regret.
So another issue with Deep Sky Stacker, you know, it is hosted on some site which is sometimes blocked from India. So downloading Deep Sky Stacker becomes a bit of an issue. You know, especially if your ISP is one of those government ISPs, you know, the MTNLs and the BSNLs of this world, then downloading Deep Sky Stacker, the software itself might be a bit of an issue. So that's another point.
Oh, okay. If you want that software, I can upload it to a drive or something. I can share the link. I have those softwares.
Oh no, I mean, I'm sure.
Yeah, but that might be a challenge. Yeah, but okay, but I think there should be some mirrors. But you know, again, in today's world, it's difficult to trust the mirror sites too. You never know what you will download.
Guys here, most of the guys here will have some VPN into US, so they should be able to stack. But I just thought I'll mention this here because if people try to.
Yeah, if someone tries, you know, if they have a problem like downloading the software, you know, and if you need that, maybe you can share with them, or you can ask them to contact me, or you can come through Jay and I'll provide the software whichever you want. It's not a problem if someone faces the issue. But as far as I would say, go with the Deep Sky Stacker, because PixInsight stacking is, you know, this kind of advanced level. So you can do it only if you know PixInsight very well. I am still learning stacking in PixInsight. I just tried once using a YouTube tutorial, but that was the last time. It took like 8 hours for me. I never did that again.
Yeah, so try the new weighted batch processing in PixInsight. So that also has it has some presets also. So it might.
Yes, that's how you know, that's how the workflow is in PixInsight. You have to do the batch pre-processing and then go to stacking.
No. So I just there's a new one called weighted batch processing now, where you have presets. Okay. You know, you can say that I'm actually going to process a nebula. So it tweaks a certain parameter. So you don't have to, you know, otherwise there are zillions of options, right, in PixInsight to stack.
Yes.
It actually simplifies. So next time, you know, it might
I'm
be.
going to try it. I'm definitely give it a try. Yeah.
Weighted batch script.
I think there's some question. Why do you need to take so many pictures with same settings, and why is like, are you wearing settings in the picture? Okay, so that is from Dev. Okay, so why do you need to take so many pictures with same settings? Because you know, if you take the picture with same setting, you can of course vary the settings, but then when you take the calibration frames, you have to go for, you know, multiple sessions for the calibration frames. And why you're taking so many pictures? Because you're going for longer exposure. You can go for 1 hour exposure if your camera and your gear is capable of handling noise. Like for example, you have a cool CCD, you can go for 1 hour. That's not a problem. But then make sure if you go for a single long exposure, your image may be washed out. So we don't want that. So that's why we are going for multiple images with shorter exposure. So you have the details captured, and then you're going to stack to average out the values to remove all the noise and get more signal than noise. And are you varying settings while taking the pictures? No, I don't vary because you know, it would be a headache to vary the exposure settings every time. So it isn't easy, like, you know, just set one sweet spot and just set the intermittent and just go. If you want, you can go and sleep till the exposure is done. So that's why, you know, I would not recommend varying your settings, because varying your setting is like, you know, varying your noise again. So to get rid of that noise, you have to have those many dark sessions again. So that's a waste of time. I hope you're convinced with my answer. What is the approximate cost for all the equipment needs? Yeah. So it depends on, you know, what kind of things you're going to buy. The most expensive thing I would say in astrophotography is the mount, and that's the most important thing. My setup, I got the Star Venturer for like $424, including the wedge, the mount, the declination bracket, and the counterweight. Then my tripod is around like some $180. Well, the camera is the cheapest. I got like $140, and the lens around $500. So it depends. You can my gear is like around not more than like $1,200, I guess. But then it's up to you. If you are going for a mount like a EQ6R mount, that comes like around $1,200. So only the mount goes that much, and then comes the scope and come. So it absolutely depends on your budget. If you are very low on your budget, you can try a barn door tracker. So that's something called as BARN barn door tracker. So that's basically just a custom tracker. It's a DIY tracker. You can search on the YouTube. They have tutorials and you can use that. So that's basically like, I don't know, somewhere $20-25 tracker. So it tracks till 1 minute pretty well. So you can use that. And the maximum budget, I'm not sure. I know a guy who has a rig worth like $30,000. Yes, the barn door tracker, you typed it correctly. So that's the one you can. How well is the polar altitude adjustment in the sky watching the wedge? Does it stay put or stay out when locking the knob is loose or? Well, the SA is very stable when it comes to polar alignment because it locks the the wedge perfectly. So it has a knob where you can loosen or tighten your this screw. So it stays in place a lot of time. I mean, I go for the entire night. I've been like imaging for the entire night. It doesn't move at all. So it's pretty stable. And what's the next question? Testing of Polaris for the base direction heavy system test. Yes, of course, the payload does matter. Like for example, the Skywatcher has a payload of, I guess, around 6.6 lb, something like that. So I think for 3 or 4 kgs is the maximum what you can go. After that, you might get issues tracking, or balancing the stuff. So that's the thing. So of course the weight matters when it comes to the tracker. That's why I said depending upon your gear, you have to choose your tracker. There's one mount called iExhaust 100. So that basically takes gear till 6.5 kg. So that's one tracker I would recommend, because if you are starting, that comes in the same price of Star Adventurer, and it has a go-to. That's the advantage of that mount. When I bought this tracker, I had no idea about that because I was just beginning. So I had no idea about that there exists a tracker with a go-to. Otherwise, I would have gone for that. But trust me, that's a good tracker, that iExhaust 100, where you can. It has a go-to control, so you can take your camera with a remote control where you want. So that's the one you can go for. Is there any other question? Okay, so I think that's all. Okay, so that was basically about the stacking, the softwares, and post processing. So I would show you one sample image, like what is the difference if you see after stack. So if you see the first frame here, that's the raw frame I took, the CR2 file that I took from the camera. That's for the Dark Horse Nebula. So this was a single 4-minute sub with a CLSTCD filter. It's a 4-minute sub. I've taken ISO 1600 and f4. This was taken using Canon 50mm prime lens f1.8. Then when you stack, you see like the stack is more smoother after you stack. So this is like 1 hour stack. So it's like 15 frames of 4 minutes. So that's 1 hour stack. So this is basically 1 hour total integration after averaging. And then you post process in PixInsight and you get these details out. So if you can see the nebulosity, the dark nebula coming out, the dust, the Milky Way galactic dust, you see the details behind. So this is how it makes a difference. You get much details when you post process a stack. What are you saying? That's a question. Guys, am I the only one not able to follow? This is the first image I took. Guys, are you able to see my image?
Hey, Pushkaraj, no, for some time now, I'm only seeing the list of stacking software. And so first I thought it was, I don't know. Like you talked about all the mount, all through that, I was only seeing this software image. Do I need to sign off and sign back in?
I'm seeing raw versus stack versus post processed.
Okay,
Yeah, that's the slide I'm on.
Okay, then it's fault at my end. I can see Pushkaraj's video, but not the software, not the screen. All right,
Okay.
I'll go back and come back in. Sorry about interrupting.
Okay. So you can see the difference, right? Um,
Yes.
how like what is the raw versus stack versus the final the processed image.
So this raw on the left is a single frame.
Yeah, that's a single frame right out from the camera, the CR2 file. I just open it in the Picasa image viewer and just take on a screenshot. That's it.
Yeah, but that single frame is for how many? 4
Yeah,
minutes?
it's a 4-minute single frame. Yeah.
Yeah, but even that, for within 4 minutes, you get that cloudy image. That's amazing.
Yes, you do. Yes, you do get. You have to be in the dark skies for that. I was in the bottle class 3 sky, where there's basically pretty very low light pollution. So
Okay.
you get those details. Yeah, that's the reason you have to go for the tracked photography. So you can go for longer frames and you get much details.
Yeah, yeah. I mean,
Yeah.
I can. I mean, I was about a month back or Diwali time. I was in one place where I have seen this cloud dust.
Oh yeah, you can see that. In that time, the Milky Way is pretty up. I mean, not exactly very up, but it's still up Milky Way core, and you can see the cloud dust in the dark skies. If you go to class 4 and less, like class 4, class 3, class 2, or class 1, you can see the Milky Way core with your naked eyes. It's amazing. It's a very good view. From bottle 1 sky, I mean, I've never been to bottle 1, but few of my friends who stayed in bottle 2 and bottle 1, they say that they can even see this pattern barely with the naked eyes. So that's interesting.
Okay.
The Horse Nebula, yeah. This is the Dark Horse Nebula because it looks like a dark horse.
So Pushkaraj, which are your locations for this astrophotography normally?
I basically did the images in Costa Rica, so I can tell you about Costa Rica if you want.
Acha, acha, no.
Yeah, when I was in India, I never had a track exposure. But yeah, in India, where are you located at? Because I'm in Mumbai and I know there are a few places in the Sahyadris where you find a dark skies,
Yeah,
like the
yeah.
Ragged Fort. Yeah, so you can go there. I normally go there. Yeah.
Okay.
Then you must have noticed, like, I was talking many times about the class 1 sky, class 3 sky, class 4 skies. So what are those class 4, class 3 skies? I'll tell you. So that's basically the bottle scale. So bottle scale is just, it spreads across 1 to 9 is a number scale. And it just, ranks the quality of your sky. So the bottle 1 sky is basically darkest with zero light pollution. For example, if you go to Himalayas, that's bottle 1 because there's nothing there. There's no city, maybe a few tents or maybe, few people camping there. So that's basically nothing. There's no light pollution. So those basically the bottle 1 skies, the darkest skies that you will find on the planet. Bottle 9, well, where you see only the satellites. There, for example, Mumbai, the center of Mumbai is like bottle 9. The New York, you can say, is bottle 9 sky. So basically what you see just few bright stars like Sirius, or maybe you see some planets like Jupiter, Saturn, or maybe the Orion Nebula maximum because it's very bright. But that's too very barely. I am living in a place which is under bottle 6, 7 skies. So for me, Milky Way core is not visible at all, but I can do capture the Milky Way core with longer exposures. So I stay in bottle 6 and 7. If I go towards north, I have an airport in the north, so that goes to 7 and 8. So basically, I cannot capture any image in the north for me. That would be very noisy image I do get. So even for me, the CLS filter doesn't work there. If I go to east, I have like bottle 6, so that's where I normally do all my imaging stuff. And I do have a bottle 5, but that's in the south. But unfortunately, from my apartment, it's not visible because I do most of my imaging from my balcony. So for me, only the northeast, east, and southeast is visible. So on average, I'm basically into 6 and 7 bottle skies. And this is the website. I've given the light pollution map.info, where you can find the bottle scale of your sky. You just open the site, it has a map, just tap your location and it will show what bottle you are in. So if you want a good noise-free images, I would recommend going to bottle 4 and below. Bottle 5 and above, you may feel a need to use the light pollution filter. So I use a astronomic CLS CCD filter. So that's a city light pollution, city light. I am not remembering the full name of CLS. I think it's city light suppression, something like that. So it's a CLS filter which I use. So that basically has to deal with the little bit of noise or light pollution which I have in the east.
So most of your photos are in bottle 6 skies?
Yes, most of them are bottle 6 skies. The recently which was there, that Witchhead Nebula was in bottle 4 when I traveled to dark skies, but most of them are in bottle 6 skies.
So the CLS filter fits on top of your lens?
No, it's a clip-in filter. It fits on your sensor. It goes under the lens. So if you have the EFS lens on for Canon, you cannot use that. If it's a EF mount, you can use it.
Sorry, come again, Pushkaraj, on Canon,
Yeah.
on a full frame DSLR, Canon DSLR,
Yeah,
the filter,
yes.
you are saying the filter goes directly on the sensor, is it?
It goes, see, there are two types of filters, like one fits on the lens and the others are the clip-in filters. So clip-in filters goes under your lens. So that's directly on your sensor. So depending upon your sensor, you can buy those. You have this sensors for APS-C, for full frame. So you can buy those. So I use the clip-in filter which goes under the lens.
Okay. And
let me show you the filter.
if you can show it,
I should have it in, yeah, I have it in my camera, I guess, but I normally don't remove it.
And could you please switch on your video because we can't see
Yeah,
you.
Yeah, I'm going to do that because I had opened the chats. That's why this thing get closed. Yeah. Can you see me now?
Yes.
Yeah. So basically, this is a filter you see. So this is a light pollution filter, a CLS filter which I use. So that simply goes inside your camera. Oops. It goes here and you fit inside like this.
Oh, okay.
Yep, and then put your lens on. So this filter is a problem if you're using the EFS lens because EFS lens has some extension behind the lens, so it can break your filter. So if you're using a Canon kit lens like EFS, then I will not recommend using this filter. I mean, if you want to use a filter, then better go for EF lens.
And you can use this on an unmodded Canon also, the filter, or it requires a
if you are using a clear, I mean the CLS filter you can use on stock too. I have used on stock cameras too. I did find a lot of difference when I use it because normally they say that you should use all your filters with the modded cameras, but no, CLS filter does help with your stock cameras too. But there are some narrowband filters when you go to narrowband imaging where you cannot use your stock camera. You have to have the modded cameras. So I'm gonna tell you about the narrowband filters too.
Okay.
So I hope you are clear about the bottle scale.
Yes, very nice.
Yeah, perfect. So I'm gonna move further. So we already discussed about the softwares. I told you which softwares you can use. So I'm gonna skip this slide and we're gonna move to narrowband filters. So those who are living in a city like bottle 8 or bottle 9 skies, they still have a chance to do astrophotography with the narrowband filters. So narrowband filters basically, they are mainly of 3 types. So the hydrogen alpha, the oxygen 3, and the sulfur 2. So most of the deep skies objects which we have there, the nebulas, they are the H alpha targets. So they have the H alpha emissions, they have the O3 emissions and H2 emissions. So what you capture in, if you have seen my images, whatever red you see is basically H alpha. So that red thing, your stock cameras captures very less because it blocks you have the IR UV cut. So basically whichever these wavelengths are blocked by the stock cameras. That's why you have to mod your cameras. So if you can buy these 3 filters, I have the H alpha filter too because that's how I imagine bottle 6 too. That's why it gives me a better color of the nebulas. So you can use the H alpha filter from the cities. Then you can use the oxygen filter and a sulfur filter, and then you combine these 3 images. Like you stack H alpha images, you stack the O3 images, you stack the S3 images, and then you go to PixInsight, use the channel combination, and you can try different combinations. Like you put hydrogen alpha, you can put in red channel. Then normally if you see in the Hubble images, the SHO thing. So Hubble palette, we call it SHO. So where in the red channel, they put the S2 data. So sulfur data, they put in red channel. Then the hydrogen alpha data, they put in green channel. And the oxygen goes in blue channel. And then you get a different color of, imagine a different color palette. That's the Hubble palette. So most of the Hubble images are in SHO panel, SHO combination. So you can buy these 3 filters. I think astronomic clip-in filters are somewhere around $179 each. All the 3 filters cost the same. So if you are in city, very bright skies, light polluted skies, you can try this imaging and try the narrowband imaging. That helps a lot. And maybe someday if you go to dark skies, you can capture the data without the filters and RGB and then combine both of them, you get a wonderful image. The advantage of using of narrowband filters, as I told you, it passes only specific wavelengths. So for example, HA filter will pass only HA wavelengths. It will block basically everything, even city light it blocks. Even if you're in bottle line, it will just pass the nebulosity. You will see the nebulosity in the image very clear. An O3 filter, if you use, it will pass only the wavelengths which matches the oxygen. So only the oxygen wavelengths will be passed. So nothing else you will see in the image. Yeah, a few noise would be there, of course, because when it comes to the HA filter, if you stack the HA images, and if you open the image and extract the channels like RGB, you will see the green and blue are basically noise. You don't see nothing in that. So everything in HA goes in red channel. So that's interesting. So if you extract the image HA image into 3 channels, G and B, you can simply discard it. It's just noise. So when I do the the narrowband RGB integration like the HA RGB or LRGB, I basically discard the G and B channel for the HA data I have. I only use the red channel and then integrate with the RGB channel, with RGB image. And the limitations that I told you, this can be used only with the modded DSLRs because these are the wavelengths which are blocked by the stock DSLR. So even if you use these filters with the stock, it won't help. So you can use it only with the modded DSLRs or the CCDs. So these are basically about narrowband filters. So most of the images you see on the on the NASA the app pod and the stuff. So these are mostly captured with the narrowband filters. If you have dark skies, then you can skip using this. Of course, nothing beats dark skies. Trust me. You use any filter in any cities, nothing beats an image captured from a dark sky. So that's the thing. So you can go for narrowband filters if you want to image from a city. So this is my rig that I showed you. So this is my mount. This is how it mounts. So basically, you have a wedge here. So the mount here, you have to use this declination bracket. It goes inside this, and then you fit it, and then you mount the camera on this bracket here, and that's it. You start tracking. So pretty small rig. I don't have big equipment yet.
Can you show the bottom of that mount? How does it fit on the tripod?
Well, yes. So see, it has this thing.
Oh, okay.
Normally, like the same thing.
Okay.
Yep. So this is my small and simple rig. Nothing else. I mean, that's all. Of course, of the intervalometer and the lens heater is there, but that's it. That's the only gear I use for all my images.
So this whole gear is less than $1,500.
Yeah, it should be. See, the lens is like $500. Camera is like $140. Make it $150, including the modification. So like $650. This is like $424. So that makes like somewhere roughly around a bit less than $1,100, and a tripod of $180.
Excellent photos for the price of the equipment.
Yeah, thanks. So I'm going to show you some photos now, which I captured. Let's have a go with some of my best photos. So this is the Witch Head Nebula that I captured last week. So this is from bottle class 4 and Samian 135mm, and it's like a total of 4 hours 7 minutes of exposure. So it's a pretty. I wanted to go for this image since long, but I was just waiting to have the Samian lens. Well, the Samian 135mm is a pretty wonderful lens. It's a very fast f2 lens. It captures a lot of data. and the optics are very good. I mean, yeah, this image recently posted. I mean, I submitted this image for NASA airport, and well, they have considered it. I still haven't got the airport category, but it's still on their page. NASA has posted on the Instagram, and the other Sky. There is a Facebook page called Sky. So basically, all the submissions which they, consider for airport, and it goes for the, the public opinion. So they put it on the Sky page. So this image is posted by them yesterday. So this is a 4 hours. It's a witch head nebula because if you see, the face looks like a witch looking at the star. So this basically, this nebula is, it shines because of this star. It's a regal. It's a star from the constellation of the Orion. So this star is responsible for, this nebula to shine. If this star was not there, this wouldn't be visible to us at all. Then this is the Rosette Nebula and the Cone Nebula. So the Cone Nebula is very small. If you see the small pointed structure here, it's very small. So that's a Cone Nebula, and it's called a Christmas tree cluster because it's in the shape of Christmas tree. The stars here, and it's designed like a Christmas tree. Like you put the lights on the Christmas tree, like a Christmas tree structure. And if you see this nebula, if you happen to see a very zoomed image, a very clear image taken by some bigger scopes, it looks like a fur of a fox. So it's also called as a fox fur nebula. And this basically is a completely H alpha target. Whatever red you see is the hydrogen alpha. And this is a Rosette Nebula because it looks like a rosette. And it's I have used my HA filter. So this basically is a mixed data. So the RGB data I captured from the class 4 skies. So that was around like 3 hours of exposure. And then I came home, and from my place from bottle 6, I again took only the HA part, another 3 hours. So total integration, it went around 6 hours, 23 minutes. And so it's a combination of the HA and the RGB together. Then this is the Milky Way, which I captured like last year from a class 3 sky. So this is a volcano here. It's pretty dark. There's very less light pollution. This was using my stock camera, stock Canon 1300D. So this is just the 15 minutes of exposure. Like I guess it's like 3 minutes into 5 images. And ISO 1600, which I go for. So for if anyone has Canon 1300D, this is the best ISO setting for your deep sky imaging in the dark skies. And this is with the kit lens, 18mm lens, taken at f3.5.
Is this
the bright star you see
from a balcony?
Sorry?
Is this from your apartment balcony?
No. This is from a bottle class 3 sky. Which it's a volcano here. I traveled there to capture this. So that's why you see a lot of details here. I never captured Milky Way from my place because it's basically towards the south. So for me, there are many objects that come in the way. So I never tried to capture Milky Way, but they didn't come up good because it had a lot of gradients because of the street lights and the stuff. It's very low, and the time it goes high in the sky is beyond the roof for me. So the bright star you see in the center, that's Jupiter. So in 2019, Jupiter was here, and the star, this thing you see here below, that's Saturn. So Jupiter and Saturn were so far in 2019, and now they're coming together. Then this is the image which I showed in the comparison of the raw versus stack thing. So this is a dark horse nebula. It looks like a dark horse. If you see, it looks like a horse. The mouth or the head of it, the 2 legs and the stuff. And this is it's called a Rho-Ophiuchi cloud complex. It's because it's near the star called Rho-Ophiuchi. So Ophiuchi is a constellation, and the star Rho of it. So it's near that star, so it's called a Rho-Ophiuchi complex. It's an amazing target to shoot. This is with a stock camera again, so you can see the details I could capture with a stock camera in the dark skies. Of course, there is some H alpha part here too. So this part is an H alpha part. So that's why I was not able to get it clearly because it was stock camera. So I did not get much on H alpha. But you can see the yellow thing around the star called Antares. That's in the Scorpius constellation. So Antares is basically it's called the rival for Mars because earlier it was confused between the this star and the Mars, because the star is a yellow it's a supergiant, so it looks yellowish in the sky. I mean, it's, if you see Mars and Antares, they look somewhat similar. So earlier it was confused, so that's why they call it the rival of Mars, the star. Then this is the wide field of Andromeda and the Triangulum galaxy. This is again from bottle class 3. It's just a 45 minutes exposure with Canon 50mm lens at f4. So this is the Triangulum galaxy, and this is the Andromeda galaxy. You can see the two small fuzzy spots here. This one and a bit here. So these two spots are just the satellite galaxies of Andromeda. So Andromeda is named as M31, Messier 31. So this is Messier 32 and this is Messier 110. So no, this is Messier 32 and this is Messier 110. So basically there are 3 galaxies in this field and 1 galaxy here, that's M33 or the Triangulum galaxy. So this is again in the bottle 3 dark skies using the stock camera 1300D and the Canon 50mm lens. And this is the close-up of the Andromeda galaxy, which again from the same spot, class 3. This is with the 55 to 50 lens, the EFS lens. I set it to 135mm at f5.6. I set it. You see some minor twirls on the star because I was a bit off the polar alignment. Alignment was not perfect, and it was like 2 degrees out there, and it was pretty windy kind of stuff. So I had no guts to go outside my tent again to align. So I just left it as it is because I was almost about to end my session and the last 1 hour I had left. So I just thought to give it a go on Andromeda. So I gave it, but it came up pretty nice. You can see some hazy, halos around the stars. That's because the sky was hazy. It was foggy at that time. So, but again, the image came out pretty good as compared to the foggy skies. So that's at 135mm. Of course, it's a cropped image because it's not the exact FOV that you get at 135. So it's a cropped image. Then this is from bottle 6, I would say, which I captured from a balcony. This is using my modified DSLR. So I would say this is the first light for my Samyang. So when I got my Samyang 135, this was the first image I captured. So you can see a part of the Orion Nebula on the right side here. Then you have the Running Man Nebula and the Horsehead Nebula. This is one of the very famous nebulas, the Horsehead Nebula and the Flame Nebula. And you can see the HA region around it. The main goal behind capturing this image was this comet. So if you see on the left side, the green thing is a comet. So there was a comet. The comet was there a few days earlier. It was near the Orion Nebula somewhere around here. But at that time it was cloudy, so I could not capture the image. The Costa Rica has a big problem with the clouds, the weather here. So we are in summer, but we still have the dark clouds. So this is a comet named Atlas. So this was in the 14th magnitude at that time. So there was no way to see with the naked eyes, but I still managed to capture in the bottle 6 skies. And a little bit of the Barnard loop you can see on the left-hand side corner, that thing. Then the moon, which I captured last time using the 250mm lens. So you see the colors. That's basically when you adjust the hues and saturation. So I call it a mineral moon because if you increase the saturation of the moon, you get these colors of the minerals on the surface. So this I don't remember how many images I stacked, but I normally stack if I go for a moon and sun, I normally take at least 100 images. So this can be 100 to 200 stacked together, and then using PIPP I cropped and got it to center with this resolution, and then stacked it in auto stacker, and then adjust the wavelets to get the sharpness on the craters if you see on the edges using the wavelet processing in Registex, and then the saturation adjustment in Photoshop. And this was the Penumbra eclipse, which was there last month. From Costa Rica, it was only Penumbra eclipse. So you can see on the right side of the moon is a bit darker as compared to this. So that was the eclipse I captured. So I used a 2x teleconverter for my 250mm lens. So this is basically on 500mm focal length. I hope you can see the dark. The moon has gone a bit dark on the right side. Yeah. So that's basically the penumbra of Earth. Then this was the eclipse I captured in 2019. Again, this was the maximum we could see from Costa Rica. So I had used a solar filter on my lens. So the eclipse which I captured. Then these are the sunspots which I captured. Like last month, there was a big sunspot. The sun is getting active. Fortunately, that's a good thing to know for the amateur astronomer. The sun is again getting active nowadays because our sun normally has a cycle of 11 years to get active. So 11 years it's very active. So you see many sunspots, many solar flares on the surface. And 11 years is again next 11 years it will be silent. You'll see minimal activity on the solar surface. So this was the spot like a few weeks back. So I think it's active region 2786. So that's approximately size of 3 to 4 times of Earth. So you can fit in like 3 to 4 Earths in this. That's how big it was. So there were like 4 solar spots. One went behind the surface when they captured. So you can see one solar filament here, one big spot here, then another spot here, and this sunspot here. So sunspot is just the comparatively cooler surface on the sun's surface. So not cooler, of course, but as compared to the other part of the sun, they're cooler. So that's why they look darker to us from here. And this spot was pretty interesting because I tried to see it from my binoculars with a solar filter. Of course, I could see that spot between the binoculars itself. So it was very big. And yeah, so this is basically. Can someone tell me what is this? Can you guess what is this?
Eclipse.
Venus.
Yes, that's a Venus. That's Venus. That's Venus in daytime. So Venus is, basically in planetary images, you have hardly 4 objects to image. I mean, except for the sun and the moon. Like you can image Jupiter, Saturn, and Mars. Venus is basically, it's not that good to image because it's very bright. It's very difficult to adjust the exposure, and basically you don't get any details on Venus, unless you have a very big scope, of course, because it's completely white due to the clouds on it. So only interesting I like about Venus is like it shows phases like moon because it's between the sun and Earth, so we can see the phases like moon. So and Venus is one of the objects which we can see like even at 1 p.m. in the day. So this image was captured around like 4 p.m. when it was sun was out there. So I just tried to give it a go because I was just trying to search Venus and I could see it with my naked eye. So that's interesting. Venus, you can even see the naked eyes at 1 p.m. in the day if you know where it is. It's very bright. So I just captured this with, I think that's at 500 mm, again, 2x teleconverter, single image. So I was captured to, I managed to capture the crescent of Venus. And as compared to moon, it looks like this. So this is a composite, basically. So same Venus image, I just put the moon crescent on it. So it's pretty interesting, like how Venus moves across the sky. So those were the few of the images. So I hope that was I made at least few points clear about the astrophotography. Now let's move on to question and answers. If you have some questions, you can ask.
Firstly, let me say on behalf of everyone, it's been a superb presentation. Lots of information.
Thank you so much. I should actually thank you for that.
Unbelievable knowledge.
This, yeah.
Unbelievable knowledge and willingness to go out and experiment.
Thank you so much for that. Those words. Yeah.
No, the main thing I notice is for the price of equipment, you are getting some really good shots. The nebulas and all, they're really fantastic.
Yes. Well, that's what I said. See, astrophotography is something, if you have the budget, it can go to thousands of millions of dollars, you can go for that. But it's normally, when they ask me what is the best camera for astrophotography, and my simple answer is like, the best camera is what you have right now, right? If you know your device well, you can, there are certain limitations. Of course, I cannot compare my images to Hubble images. Of course, there's no way. But then, there are two options. Either you empty your pockets, or do the best of what you have. I would say do the best of what you have because you start learning, the challenges, what you face, you overcome the challenges. So you don't get those challenges when you upgrade your equipment. I many of the, these events I go for my session, there are people who are asking me like, what kind of equipment shall I buy? Shall I go for this mount? Shall I go for that mount? I say, well, if you have the budget, if you have money, just go for it. just go for it. But then understand that the bigger the mount, the bigger the equipment is, the more the complexity of that gear is. So at one point of the time, like, if you say that, oh, I'm not able to understand how this works. For example, there is something called as guiding. So they use a guide camera on your equipment. So guiding basically improves your tracking. So it's like guides your camera where to stay. So in the guiding scope, you have to, maybe adjust a star or something, and then it gives you more accurate polar alignment. But then if you don't know how to use that gear and you just invest it, and then at one point of time you get bored, I'm not able to deal with this, I give up, you wasted your money, right? Then again, if you go to the EQ6R, you can align your mount with the software. It directly goes with like a sharp star alignment, and you can directly go and align it perfectly. You don't have to do anything. So they say it's easier, let's go for this. But then what if you go to some place where there is no electricity? Now you have to mount it manually. What would you do at that time? Then you don't know what to do because you are used to machines. So I always recommend, like, start with small thing, learn the basics, learn how stacking works, learn how to frame objects, learn how tracking works, learn how to polar align, then go for the bigger thing. Then upgrade your equipment. I know you'll spend a few bucks extra, but that would be worth, because instead of spending like thousands of dollars and then giving up on the equipment and then selling that equipment, better start with a few hundreds of dollars, learn, and then put more $100 and make a good equipment. Am I clear? I mean, do you agree with this? That's what my approach is. Yeah. I have seen
Makes
people
sense.
using EQ6R mount. I have seen people here using the Orion 10-inch scope. EQ6R mount, they have like big mounts, big scopes, they use guiding, they use star sense alignment, they use everything. And images, what I see, like, they don't make justice to the gear they have. I said, why? I mean, I have seen guys, they don't go for 30 seconds exposure. It's like, no, I'll burn my sensor. I said, if you're afraid about going more than 30 seconds on your camera, then astrophotography is not for you. I go for like 3 minutes, my camera is still working for last 3 years. You have to go. I know there is a risk on getting for longer exposures, but of course the camera is not that weak that it cannot handle a 3-minute exposure. It can even handle 30-45 minutes exposure for sure. So that's how it is. So if you want to start with the gear what I have, do some basic upgrades, go to tracking mounts. If you still don't want to invest like $400, then learn, go for the Bando tracker on YouTube, go for one minute exposures, learn stacking, learn tracking, and then upgrade your mount. So that's how it should go. That's what my opinion is. So you can ask any more questions if you have about. Yeah, one more key point I would tell you: when you shoot, on your on deep sky, always step down your aperture. So like if your lens is like f1.8, for example, 50 mm lens, it has an aperture of f1.8. Step it down to f4. The reason, if you shoot your image is very wide open, the stars what you'll get will not be sharp. So it can be, you might get some coma on the stars, like on the edges the stars will be elongated, or the stars will be like bloated kind of stuff. So if you step it down, I shoot at 50 mm at f4, so that's your pretty sharp stars, very less to negligible or to zero coma on the edges. My stars are even sharp at the edges. So always step down, at least go 2 to 3 steps down on your lenses while shooting it. Of course, if you're shooting it wide, like it is prime lenses, I first of all, I will not recommend for a good astro, but to learn, you can use it. You can still do astro with that, because sorry, not the prime lenses, my bad, I'm talking about the kit lenses. The kit lenses have the very bad chromatic aberration. Like for example, the Canon 1855 lens, I am still not sure what's the point of making that lens, because I hate that lens a lot. It has such a worse chromatic aberration. My stars have the violet circles around it. It's crazy. But I will not throw it up, because that's where I started. So somewhere that lens plays a part, in my progress. So you still can do astrophotography with such a cheap gear too. So, but step down your lens a bit, and you'll get a sharper star. So that's the key point I would tell. Anything else you want to ask about the celestial events, how to capture? You can ask me.
Wonderful presentation, Pushkaraj. I just want to ask whether you have captured the recent Saturn and Jupiter conjunction.
Well, No, because I am not into planetary much, because for planetary, the challenge is like you need a very big focal length. So the maximum what I can go for right now is 500 mm. So for a DSLR sensor and 500 mm is nothing. So you will capture 2 stars, nothing else. But for to get the details of Jupiter, I would say you will need a focal length of at least 1000 mm. So at least 1000 mm, and then go for these shorter exposures, because the lower the exposure, you'll get more details on it, because the Jupiter Saturns are bright. So if you go for longer exposures, they'll be just like stars, nothing else. So if you want to have the surface details, you have to go for the lower exposures. I'm sure the planetary guys which we have in the session, they already know it. The Saturn they captured, that was amazing. It was amazing. The details, I was quite impressed.
Yeah, thank you.
So yes, so go plan this conjunction, because it's I think it's almost up 800 years this conjunction is taking place, and it's gonna be in one single frame. So don't miss the conjunction. If you have telescopes more than 1000 mm, just go for it, take them. You can even capture this the conjunction with your cell phone. I have a friend in Mumbai. He has a 6-inch Dobsonian scope, and he captures all his images with his Redmi Note 7 Pro, and that's amazing. So you can even use that. So basically what you need is the wider focal, the longer focal length, bigger focal length, that's it. And for deep sky, it's inverse. You need a faster scope. So if you have you need a wider exposure for a deep sky. So the more the exposure, more details will capture. So basically, if you're planning to buy a scope, make sure the scope is like f4 or lower. So f4 is basically the considered to be faster scope. So f4 and lower. So there are scopes which are like the focal ratio of f2. So like the RASA scopes, and also they are like pretty fast. So plan for such scopes. Focal length, you can go for as per your needs. So but what matters is the aperture for the deep sky, because you have to let more light come in. So anything else you want to ask, Amir?
Well, looks like no further questions. There's something in chat. What did you say?
Oh, let me see, because I'm connected on a phone. So okay.
Yeah. Are you on Facebook, Instagram?
Yep, I'm there. You can. I'm gonna give you my.
Can you type your signature on Facebook and Instagram?
Yep. So. So I think I only typed with Jesh. Let me put it to everyone. Yeah. So this is my my profile is Pushkaraj Naringrekar. I have an FB page which I started recently. It's called Astro, and my Instagram is Astro07.
Okay.
So you can follow me there. I keep on posting. I sometimes do wildlife images too. So like the name says Astro07, but my Instagram feed is full of the other nature images too. So that's it, guys, from my side.
Okay.
I hope
Thank
you
you, guys.
enjoyed the presentation. And I really want to thank all of you guys to giving this opportunity, because let me tell you, this was my first presentation like this on deep sky, and this was definitely a new learning for me. I definitely got some points which I can maybe improve or add later in my further presentation, but at least I got a kickstart, and I really want to thank all of you for giving me this opportunity. And I hope you enjoyed the session, and I hope you got at least I was able to convey some knowledge at least.
Yes. Thanks. And we'll sign off for the day.
Yep.
This recording will be available on YouTube, and Pushkaraj, you can get the link too. Jayesh will forward you the link. So
perfect. That sounds good.
Okay.
Yep.
Thanks,
Thank you so much, guys. Signing off for now.
Thank you.
Hope you have clear skies and enjoy the presentation.
Thanks.
Enjoy the connection.
Thank you, Pushkaraj. That was fantastic. Thank you.
Yep. Thank you
Thank
so
you.
much for being patient.
Oh, for this kind of knowledge, always welcome.
Yep. You can ping me in person if you can come through Jayesh or something. If you have any queries, you can ping me anytime. I'll definitely make sure I answer your questions. Or you can ping me on Instagram directly or Facebook directly.
Okay. Okay, sure. Yep. Okay.
Yeah. Thank you so much. Signing off.
Have a good day. Bye.
You too. Bye.